Good morning everyone. My name is Hiram. In this video, we'll be discussing a chapter called Triangle of Class 10 CBSE. This is the first video of a playlist. In this playlist, we'll be learning triangles through textbook, exercises, some worksheets, and some other important concepts. By the end of this playlist, we'll have a comprehensive idea of what a triangle is and what are its properties. Now, what is a triangle? Yes, the basic definition of a triangle is it is a polygon having three sides. There is a lot more than that in a triangle. A triangle has many properties. To know about all these properties, we should discuss a concept called similarity. Many of the properties of these triangles are deduced from a concept called similarity. So let's discuss similarity. For every body, there will be two parameters, shape and size. If two bodies are having same shape, then they are called similar to each other, irrespective of size. If two bodies are having same shape and same size, then they are called congruent to each other. I am sure this congruent term came for us in 9th class, correct? So if two bodies are having same shape, they are called similar to each other irrespective of the size. If two bodies are having same shape and same size, that means those both bodies should be exactly equal, then they are called congruent to each other. For example, let us take circles. I am taking two circles. One is of smaller size, one is of bigger size. Now, what is the shape of this circle? It's round in shape. What is the shape of this circle? This is round in shape. Now, no matter what the radius is, two circles will always have same shape. So, two circles are always similar. Any two circles are always similar to each other. Now, let us consider similarity of squares. There is a smaller square and there is a bigger square. No matter what the side of a square is, two squares are always similar to each other. That means two squares will have same shape no matter what their side is. So two circles are always similar to each other and two squares are always similar to each other. As we discussed, two circles are always similar to each other and two squares are always similar to each other. Now, are any of the two triangles similar to each other? Let us take an example. Let me draw random triangles here. This is a triangle and this is one more triangle. Are these two triangles looking similar to each other? No. Why? Because these two triangles are having different shapes. So you can't tell two triangles are not always similar to each other. Now, how to decide if two triangles are similar? There are two conditions to decide whether two triangles are similar to each other or not. Now, first condition, if all the angles of the two triangles are same. Let us take in this example, angles of these triangles are 30, 50 and 100. Angles of these triangles are 30, 50 and 100. So, if two triangles have exactly same angles, we can say that those two triangles are similar to each other. Correct? Now, one more condition, or. Why I wrote this or, and this or is very important. I'll tell you why. What is second condition? If the ratio of sides is same, that means, now concentrate carefully. What are sides here? 2, 3, 4. Now 2 is to 3 is to 4 is the ratio of the sides. What is ratio of sides here? 4, 6, 8. What is ratio of 4, 6 and 8? It's nothing but 2 is to 3 is to 4. If ratio of sides are same in both the triangles, we can say those two triangles are similar to each other. Not only 4, 6, 8. You can have some common multiple like 3. If you multiply this with 3, 6, 9, 12. Finally, the sides of the triangle should be proportional to each other. I hope you understood this. We'll discuss about this more in our concepts. Now, why we have discussed or? That means any of these two conditions is satisfied, we can tell that two triangles are similar to each other. What is the meaning of this? That means if angles of two triangles are same, then automatically sides of the triangle will be proportional to each other. That means if two triangles have same angles, then ratio of the sides of those triangles will be automatically equal, and those two triangles will be similar to each other. Are two equilateral triangles always similar to each other? Well, what is the condition for two triangles to be similar to each other? Angles inside the triangle should be same. Well, all the angles in the equilateral triangle are equivalent 60. Whatever equilateral triangle you may take, angles of the equilateral triangle will be 60. Let us compare triangle 2 and triangle 3. All the angles in the two triangles are equal, so automatically these two triangles are similar. Sides ratio. What are ratio of the sides in any equilateral triangle? It will be 1:1:1. Why? Because all the sides of the equilateral triangle will be equal. 3:3:3 will be 1:1:1. Well, if these two triangles are similar to each other and having same side, that means size of the triangle is also same. So triangle 1 and triangle 2 are congruent to each other because not only shape but also size of the triangle are same. So we can tell all equilateral triangles are similar to each other. Like all circles are similar to each other, all squares are similar to each other, and all equilateral triangles are similar to each other. To decide two polygons are similar, all corresponding angles should be equal. That means all the angles inside the polygon, that means 80, 60, not only 80, 60, 100 and 120, it's an example. 80 should be equal to 80, 60, 60, 100, 100, 120, 120. All the corresponding angles should be equal, and that means condition 1 and condition 2 both should be satisfied. What is condition 2? All corresponding sides should be in same ratio. That means, see here, 2:3:4:5. Here what is the ratio of sides? 4:6:8:10. What is 4:6:8:10? If we simplify, we'll get 2:3:4:5. That means corresponding sides ratio should be same, and angles inside the quadrilateral should be same. Not only quadrilateral, polygon, any polygon having same angles and corresponding ratio of the sides should be equal. Now let us observe figure 6.5. In figure 6.5, we have two quadrilaterals. Let us decide whether these two quadrilaterals are similar to each other or not. We have two quadrilaterals ABCD and BQRS. Now what is the first condition for two quadrilaterals to be similar to each other? Corresponding angle should be equal. Angle A is equal to angle P, that is 105 degrees here. Angle B is equal to angle Q, that is 100 degrees. Angle C is equal to angle R, and angle D is equal to angle S. Hence we can say corresponding angles are equal. So our first condition is satisfied. Let us check for second condition. What is the second condition? Corresponding sides should be proportional, right? Now let us observe side AD. What is length of AD? 2.1 centimeters. Which is the side proportional to AD? That is PS. PS is 4.2 centimeters. 4.2 is exactly twice of 2.1 centimeters. So the corresponding sides ratio is 1:2, right? Let us check whether it is maintained for all the sides. Length of AB is 1.5 centimeters. Its corresponding side PQ's length is 3 centimeters, which is exactly twice of 1.5, right? Length of side BC is 2.5 centimeters. Its corresponding side QR is 5 centimeters, which is exactly twice of 2.5 centimeters, right? Length of side CD is equal to 2.4 centimeters. Its corresponding side RS is 4.8 centimeters. 4.8 is twice of 2.4. So our corresponding sides ratio is 1:2, is maintained for all the sides. So corresponding sides are proportional in these two quadrilaterals. So both of our conditions are satisfied. Hence we can say quadrilateral ABCD is similar to quadrilateral PQRS, since both the conditions are satisfied. Now let us observe figure 6.6. In figure 6.6, we have two quadrilaterals, quadrilateral ABCD and quadrilateral PQRS, right? As we can see, both of these quadrilaterals are rectangles, right? We all know that in a rectangle, all angles are 90 degree. So definitely corresponding angles in these two rectangles will be same. So our first condition is satisfied. Now let us see whether second condition is satisfied or not. Let us observe side AD. AD is 3 centimeters. Its corresponding side PS is also 3 centimeters. So corresponding ratio is 1 is to 1. Right? Now let us check whether it is satisfied for other sides. Length of side AB is 3 centimeters, but its corresponding side PQ is 3.5 centimeters. Here our corresponding sides ratio is not maintained in these two quadrilaterals. Hence, second condition is not satisfied. As we discussed, any one of the condition is not satisfied also, these two quadrilaterals will not be similar to each other. So in figure 6.6, ABCD quadrilateral is not similar to PQRS. Now let us discuss figure 6.7. In figure 6.7, we have two quadrilaterals ABCD and PQRS. As we can see, all sides of ABCD are equal and all sides of PQRS are also equal. ABCD is a square and PQRS is a rhombus. Definitely corresponding sides ratio of ABCD and PQRS is same. Why? Every side is 2.1 here and every side is 4.2 here. So all sides will have the same corresponding side ratio, which is 1 is to 2. Our second condition is satisfied. Now whether our first condition is satisfied or not, corresponding angles should be equal. Here all angles in ABCD are 90 degree, but in PQRS there is no angle which is 90 degree. So corresponding angles are not equal in these two quadrilaterals. So since any one condition is not satisfied also, we can't tell these two quadrilaterals are not similar to each other. So to wind it up, in figure 6.5, we have both the conditions satisfied. That's why ABCD is similar to PQRS. In figure 6.6, we have second condition not satisfied. That is why ABCD is not similar to PQRS. In figure 6.7, first condition is not satisfied. Hence, both the quadrilaterals are not similar to each other. Now let's discuss exercise 6.1. Exercise 6.1. In exercise 6.1, first question. All circles are, we have discussed that all circles are similar to each other, right? If two circles are to be congruent to each other, radius of the two circles should be same. Now second question, all squares are, we have also discussed that all squares are similar to each other. If two squares are to be congruent to each other, they should have same side, right? Third question, all dash triangles are similar. We have discussed that all equilateral triangles are similar. Why? What is the condition that two triangles to be similar? Two triangles should have same angles. All equilateral triangles will have same set of angles, that is 60 degree, 60 degree and 60 degree. So any two equilateral triangles are similar to each other. Why two isosceles triangles are not similar to each other? Let us take two examples. Now in a triangle 1, which is an isosceles triangle, let us say angles are 100 degree, 40 degree and 40 degree. In triangle 2, which is also an isosceles triangle, angles are 80 degree, 50 degree and 50 degree. Now these two triangles are not similar because angles of these two triangles are not same, even though they are isosceles triangles, right? So any two isosceles triangles are not similar to each other, but any two equilateral triangles are similar to each other. Fourth one, two polygons of same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. That's what we have been discussing till now. Second question, give two different examples of pair of similar figures and non-similar figures. Now it is your duty to observe around you in your day-to-day life and give me any two examples of similar figures and non-similar figures and comment below the video. Third question, state whether the following quadrilaterals are similar or not. In figure 6.8, we have two quadrilaterals, PQRS and ABCD. Now let us take the ratio of PQ and AB. 1.5 is to 3. As 3 is twice of 1.5, ratio is 1 is to 2. And obviously this 1 is to 2 ratio is maintained because all the sides are 1.5 in PQRS and all the sides are 3 in ABCD. Hence corresponding sides are proportional in these two quadrilaterals. Now let us come to first condition. Are corresponding angles equal in these two quadrilaterals? No. Why? All angles of ABCD is 90 degree and no angle of PQRS is 90 degree. So obviously corresponding angles are not equal. As corresponding angles are not equal, these two quadrilaterals are not similar. If two quadrilaters are to be similar, corresponding angle should be equal and corresponding side should be proportional. Right? Next concept. Similarity of triangles. We'll discuss similarity of triangles in our next video. Thank you for watching the video. If you like the video, please like the video. If you don't like the video, please dislike the video. If you have any suggestions, please comment. Please share the video. For more content, please subscribe and click the bell icon. Thank you.